the units of omega are radians per second, or radians really, we'll pretend right there. 1 over seconds divided by 1 over meters, which ends up being a meter per second, which works. Okay, so we have omega over k, so let's just go ahead and take this over here and solve for omega over k. So I'm going to bring k over to the left, I'm going to bring v over to the right, and so v, which equals omega over k, equals also E sub m over v sub m. So if I just take the magnitude of my electric field divided by the magnitude of the induced, sorry, make sure I said that right. If I take the magnitude of the electric field divided by the induced magnitude of the magnetic field, I will get the speed of the wave. We are halfway through. Questions up to here before we do something very similar, but just enough different to make it worthwhile. Right over here. That was from Faraday, Lenz as well. We have V equals E sub m over V sub m.
Why, when you were right there below, why did you change them to both to positives?
They're negative on both sides, so just multiply both sides by -1 to get rid of it.
Why are they? Because over here, delta B over delta T is positive?
Yes, however, the negative sign shows up
The wing, okay, that makes sense.
in the actual Faraday's law. All right, are we ready for the second half? Good. There we go. Now we'll start out with the Ampere's law. We're going to do something very similar, except now we're going to do a line integral or a line sum around a magnetic field. So if you think about I have my electric field going, but the electric field has the tap on it. The electric field is going up, my magnetic field is coming out towards you. I now want to look at the magnetic field, and so basically I'm looking at this. So here's my magnetic field, the electric field is going away from us. So I'll have my magnetic field, two moments right next to each other, E plus delta D. I'm going to do a line, go about a closed loop. That distance there is h, an arbitrary value. It will cancel out just like it did before. My electric field is going into the page, or into the board. And again, to determine which way we want to go around the loop, I'm going to use the right-hand rule again. Since my electric field is going into the board, I'm going to go around clockwise this time. So I'm going to label that as A, B, C, and D. It helps if I actually at least had some convention there. I'm going to start there. A, little b, C, and D. So this is gonna be the magnetic field along path A dot delta L along path A. Plus the magnetic field along little b plus delta L, not plus. I was joking about that. Little physics humor. Plus the magnetic field along C dot delta LC plus magnetic field along D dot delta L along D equals, there is no actual charge moving here. Because there's no charge moving, the first term on the right-hand side of the equation is 0. That I there, that's actually I enclosed, that's for actual physically moving charges. So I'm left with 0 plus mu sub naught, epsilon sub naught, and then I'm left with this situation right here. If you recall, phi sub E is A dot E. I generally write it E dot A, but commutative property holds in dot products. My electric field, I'm putting my area in the direction of the electric field, so that's going to work out, and so I end up with A times delta E over delta T. Similar to what we did before. That's one reason why I skipped some steps there. If you would like me to fill in those steps, I would be glad to. Over on the left-hand side, which of those dot products equals 0?
A and C again?
Yes, it is. Because the length A and C are horizontal, the way I've drawn it, B is vertical, A and B perpendicular. All right, so we have this B dot delta LB. So I'm over here, going this way, because I'm going clockwise. As I'm going up, B is going up, the length is going up, so the dot product is just, well, my angle is 0, it's just the product of the magnitudes. So this just becomes B times H. This over here, my magnetic field is going up, my line part is going down, or the length vector is going down, so minus B plus delta B times H equals U naught, epsilon sub naught. And my area is the area of that rectangle right there, which is H delta X times, not wrong class, delta E over delta T. Just technically, these are vectors. So it looks a lot like what we did last time, flipping B's for E's. There are some subtle differences that will work itself out. If I go ahead, I'm not going to write the vector symbol. We just know, right?
Yeah.
So BH minus BH minus B, sorry, delta BH equals U naught epsilon sub naught H delta X delta E over delta T. and the BH's disappear. Annihilate in a blaze of glory. And we are left with a much simpler form of this, which we'll get even simpler in a moment. It's about to go to new screen. So I have negative, look for H first. H delta B equals mu naught epsilon sub naught H delta X. It's supposed to be a triangle. Delta E over delta T. H cancels out once again. I'm going to divide by delta X, so I have negative delta B over delta X equals mu naught epsilon sub naught delta E over delta T. All right, so what's delta B over delta X? Again, I'm talking about the vector B here. When we did delta E over delta X, we did, well, that's just a constant, that amplitude that stays out front. Cosine becomes negative sine, and then we took the coefficient of what we're taking the change with respect to, so the K pops out.
Okay, so it would be negative, B in K sine KX minus omega T. Correct?
Omega T?
Yeah.
Yep. This negative sign, the one inside my brackets there, comes from the change of cosine becoming negative sign. The other negative sign comes from the negative left over from what we just did. That comes from there. And over on the right-hand side, I have mu sub naught, epsilon sub naught, and now the change of E with respect to time.
Maybe positive?
Would it be positive? Why?
Because, I don't know, my brain just saw the delta B over T and was like, well, that one's positive. It would be negative E M omega, right?
Close. We ran the same issue last time.
Negative omega.
Negative omega.
Yeah.
It will end
Which
up
is
being
why
positive.
it's, yeah.
You're right. That was times sine kx minus omega t. So we got we have double negatives on both sides, which is nice. So if the negative signs make a positive, sine will cancel out. For the pure stuff there, officially sine doesn't cancel out. If they're equal to each other at all times, then the coefficient of sine must be equal to each other. For practical reasons, I'm just going to say they cancel out. And I am left with the nice little equation of V sub m k equals mu sub naught, epsilon sub naught, E sub m omega. I'm trying to find speed. I know speed is equal to omega over k. I bring k over here, and I bring all this stuff over to the other side, and I'm left with v sub m over mu sub naught, epsilon sub naught, v sub m. So, from Ampere, Maxwell's law. And again, generally you just consider Ampere's law. With Maxwell's correction. We have V is equal to Vm d sub m over mu sub naught, epsilon sub naught, d sub m. So if this stuff is to be believed, then I have two different equations I started with two different equations. I solved for the speed in both equations. Both of those must be equal, if we are correct, both of those are equal to each other. In other words, I am saying that E sub m over B sub m equals B sub m over mu naught, epsilon sub naught, E sub m. I'm going to get all my E's and B's at the other side, my amplitudes over onto the left, so I'm going to multiply both sides by E sub m, divide both sides by B sub m. So on the right hand side, I get E sub m squared over B sub m squared equals 1 over mu sub naught, epsilon sub naught. If I take the square root of both sides, I get E sub m over B sub m equals the square root of 1 over mu sub naught, epsilon sub naught, or equally 1 over the square root of mu sub naught, epsilon sub naught, whichever one you fancy. And E sub m over B sub m is just the speed of the wave. So we now have an equation of an electromagnetic, for the speed of an electromagnetic wave. Let's pull the calculators. Mu sub naught, that's 4 pi times 10 to the negative 7 meter Tesla over per ampere times epsilon sub naught, which is 8.85 times 10 to the negative 12 Coulomb squared over Newton meters squared. What do we get?
Is that a negative 7?
Yes.
Yeah.
Here.
Okay. 299.8. It's a very long number. 299.863380.5.
866-380.5.
8633.
8633
80.5.
units.
Meters per second.
That's a lot of meters per second.
So that's the speed of an electromagnetic wave. Huh. Maxwell looks at this and he goes, that's pretty darn close to the experimental value for the speed of light. Because officially, what Maxwell had done up down here is just finding the speed of an electromagnetic wave. He was not, the way history is generally presented, he was not purposefully trying to find the speed of light. He was just trying to find the speed of an electromagnetic wave. But he looked at this and said, this is so close to the experimental value of the speed of light that I speculate that light is an electromagnetic wave. And that turns out to be the case. Now, at this point, that is a set value. Speed of light is actually a set value, and we can derive epsilon sub naught based upon 4 pi times 10 to the negative 7th and the official speed of light. That's somewhere close to it. In Maxwell's time, it was not pinned down yet. This is 1870s, somewhere around there.
Wow.
So we are still recovering from our Civil War. Physics as is known today was not a whole lot there in the US. Physicists looked at this and they said, that's incredible. That's actually, that's really great work, but there's a mistake. Turns out there's not a mistake.